The first pair is Campbell, Forrest and Veitch, two intrepid mountaineers. We're going to talk about the climbing and geology of Awariki Wall. Campbell and Ian.
Thanks very much. By popular acclaim, the amateur duo that brought you the discovery or the search for the Macduff boulder bed about 2 years ago, by popular acclaim, we're back again for another amateur exploration for a few minutes. The genesis of this little talk, was actually 56 years ago. And I can be absolutely precise about that because I've always been into climbing, and a couple of pals of mine made the first ascent of a rock climb on an obscure little hill beside Loch Laggan, just to the south east of Loch Laggan, called Binion Uis. And hiding round the back of this little hill was a huge cliff, and no climbers had ever really spotted it before. And when they published the descriptions of the climbs in the Scottish Mountaineering Club Journal in June 1968, this particular climb they thought was the best of its grade they'd ever climbed anywhere in Britain. So we were hot foot off to repeat it. And the thing that really got me about it, apart from the fact it was fabulous, was I was amazed to discover that you were basically climbing on pegmatite. And sometimes you were using individual feldspar crystals, like for a toe hold or finger holds. The crystals were that big. And it's always fascinated me. And there were no other rock climbs in the whole country like that. And that was my introduction to the Loch Laggan pegmatite vein complex. I've been back to the climb 12 or 15 times since then, most recently last October, and Ian and I had a fabulous day out on it in 2015, so there's one or two slides of that to show. We'll give you a little bit of background, and then we'll take a walk around the other side of the hill of Binion Uis. The hill in the back, that's Loch Laggan you're seeing on the slide there. The hill you're seeing is the neighbour of Binion Uis, which is just off to the right. And this slide from the British Geological Survey is a fabulous one showing the pegmatite veins, which tend to trend northeast, a northeasterly direction. Not exactly northeast, but pretty much northeast. Ian, can we do a couple of slides? Yep. This is just showing you the gist of Fort William is down here. This is the road across to Speyside. Here's the Spey Valley up here. And this is the area that we're focusing on, just here, beside Loch Laggan. Next one. And this is just going into it in a bit more detail. The slide that you were seeing was at this ruin of Magach, which is on the northwest shores of Loch Laggan. We're going to go walk round the back to Binion Uis here. And notable, and we'll come back to this, is the fact that these lochans here, especially Lochan na Erba here, occupy the trench of the Markey Fault, which is not particularly well known, not like the Leyden Erich Fault, but it's still a major fault. And the next slide just gives you a bit of an indication. That's the Grampian region, the overall structures. And next click, Ian. And in green there, I've basically just highlighted the Markey Fault, which runs from somewhere near the Findhorn River up there and hits more or less Ben Cruachan down here, disappearing once or twice under patches of Rannoch granite. So before we do our little trip round the back of the mountain, Ian's going to just give a little bit of background on pegmatite, what it is, the regional area here, particularly for those who maybe don't know the detail of pegmatite.
Thanks. Yes, I'm going to take you through the context that's about pegmatite. As Campbell says, we are very amateur geologists, so I've pitched this at a very amateur level, so I'm sure some of the professional geologists will know it with their eyes closed, but also spot a few errors, but if you can bear with me. Just to put it in context, we're in the Dalradian here, and the country rocks consist of pegmatites, which are sandstones that have been metamorphosed. They were laid down about 1 million to 500 million years ago, and they were metamorphosed more than once, but most recently during the Caledonian orogeny. And that's when Laurentia, Baltica, and Avalonia all collided and closed up the Iapetus Ocean. And towards the end of this orogeny, when all these continents had come together, you can imagine just what the sort of depth of rock that was involved. A series of major granitic bodies or plutons were emplaced into the Grampians. And they came from the melting of the deep continental crust, but also there was some material from the mantle itself. And these plutons cooled deep underground. Subsequently, some such as the cairngorms, we've had erosion and extensive erosion, so the cairngorms have been revealed, but others remain buried. And it's almost certain that a pluton underlies these pegmatites we're talking about today. And you'll see that in the cross section. This is here. This is the Markey Fault here. This is the present land surface, and here you've got the pegmatites and the granitic pluton below. Age-wise, the Loch Laggan intrusive complex, it predates the cairngorm granites. It's approximately 486 to 444 million years ago, and the cairngorms are more like 415 to 400 million years ago. So I talk about pegmatites, or do you want to?
On you go. Mm-hmm. Yeah.
Okay, well, pegmatite. So this is very much for the amateur geologist, but because I always thought pegmatite was a type of rock, but in fact it's not a type of rock. It's actually more of a structure than a rock. And it's actually defined, well, the word comes from Greek and means to bind together. But it's defined as a crystal igneous rock, an igneous rock with very large crystals, usually at least over 2.5 centimeters. But the crystals can be inches, feet long, they can be 30 feet long, enormous crystals can form. And the word has nothing to do with the actual mineral composition of the rock, but it's the texture that matters. So for example, you can have a gabbro pegmatite, you can have a syenite pegmatite, and in this case, you can have a granitic pegmatite, which is the most common, and it consists of quartz, feldspar, and mica. They're the main ingredients. And the pegmatite is almost always associated with some sort of magmatic pluton. But the question is, how do these large crystals occur? Now, normally, I've just assumed, we're always told, the slower the cooling, the bigger the crystals. So assumption, this must cool very, very, very slowly to grow these huge crystals. But in fact, that is not the reason. It does cool slowly, but if you think of a magma body that's crystallizing, when it starts off, it will contain significant amounts of dissolved water and other volatiles. But as the melt cools and crystallizes, the water is left behind and its concentration grows. And eventually water pockets separate from the melt, and these superheated pockets, they're very, very rich in dissolved ions. And ions in water are much more mobile than ions in melt. So they can move about and find each other and grow into large and sometimes enormous crystals. And that's what creates the crystals in pegmatite. And finally, the format. If you think of a pluton being intruded into the country rock, along its margin, it creates lines of weakness. And it may find existing lines of weakness, existing faults, or it may just actually crack the rock itself. And into these weaknesses, the solution of pegmatite can penetrate and crystallize. So what we'll be looking at is a dike of pegmatite that's formed. The solutions come in a dike and crystallized into these sort of large crystals. Over to Campbell.
Yeah. We'll take a walk round to the southeast side of this hill now, Binion Hewis. And this is what starts to appear. Instead of a sort of grassy, rather nondescript hill, you've got a pretty looming face. And this is now underneath the climb and looking along the trench of the Markey Fault, with particularly below us here, Loch Nairba. And we'll come back to that. Loch Nairba is one of the northeast, southwest faults of the Grampian Highlands. I already said the pegmatite veins tend to trend to the northeast, southwest as well, but there's a slight difference in the angle. Really is quite important. One of the things we'll say later. Now this is the face I've seen from the other side of Loch Nairba, and if we just click through here, I don't know if you can see, but that gives the kind of scale back. That gives the scale of the face from top to bottom. The climb length is 600 feet, 180, just under 200 meters. And it so happens that the middle arrow shows myself and a pal, and the top arrow shows one of the first ascensionists from 1967. And he's doing his 42nd anniversary climb of this particular rock climb on the 24th of June, 2009. So that was Dougie. That was his last one because unfortunately he died in an avalanche the very next winter. But anyway, I had the pleasure of being with him. So that gives you the kind of scale of the face. It's surprisingly big. This is starting the climb. It's about 100 feet up actually with a bit of a telephoto. And above and right of me, you're starting to see something that's not pegmatite. There's an area of samite here with more or less horizontal banding or bedding in it. The climb, in fact, turns left a bit and goes up this way. And this is up at this piece of samite. So it's right on the border of the samite over here, which is generally well bedded. Not seeing the detail there, and the pegmatite vein here. Next one, yep. This is a bit further up, and it's like a magic carpet of pegmatite that just rolls from the top of the cliff, the top of the hill, right down towards the loch. Below us, in fact, there's two of our pals, one there, and there's a tiny dot down there, and the tiny dot, if I could keep my hand straight here, he's actually about best part 200 feet up at that moment. Next one here. This is just a telephoto from a fragment taken out of another slide. It's just to show the fact that you can see some of the crystals standing out there, the pegmatite crystals, which you can actually use as holes at times. And this is nearing the top of the climb, again, Ian, and you're seeing the swoop down to Loch Nairba. Next one. Now this is getting near the conclusions. This is extremely difficult to see because of the detail, but I've circled areas where there are little blocks of samite in amongst the pegmatite. There are others than that. And I, for about 50 years, thought these would be xenoliths, just caught up in the vein. And it was only in the last 6 months or so I realized that they can't be. The bedding's all identical, the bedding angles. So to me, these look like little windows through the vein to see the country rock. And the conclusions from all that, I said it was a short talk. The conclusions, our conclusions, but I'd be interested to see what anybody else says. The rock climb itself seems to climb the sidewall of a dike, which may be 20 feet thick. It's not very thick at all, but by a freak, it happens to climb the whole way up on the sidewall of a dike. There's a heather ledge near the top. That's probably samite, and then another dike continues beyond that. And in my experience, and I have been climbing most of my life, there is nothing else like it in the whole of Scotland. It's a feature which is unique. It's totally unique on that scale. And why is it showing the way it is? Can you go back to the slide that showed Loch Nairba? Sorry about that, backing up.
Oh, well, yeah. So
That's it, yeah, that one there.
yeah.
It seems to me it's really very unusual to have this scale of feature. And it seems to me that, I mean, the ice movement was right down in forming this trench in Loch Nairba. And the angle, there's about maybe 10 degrees difference in angle between the ice movement here and the angle of the vein cutting back this way. And it seems to me it's been just plucking away, taking off blocks of pegmatite, exposing bits of samite, and then melting and leaving and exposing this, I say, magic carpet of pegmatite that runs for 600 feet down the face. That's the conclusions we've come to, but at the end of our little talk.
Thank you, you two. Now we've got